All right, let's dive right into this explainer. We're looking at a truly wild case today, literally a head-on collision between the subjective world of the courtroom and the hard, mathematical laws of complex systems. It's a clash that tests the absolute boundaries of how we even define cause and effect in the modern world. I mean, if you've ever fired off a random thought online and kind of wondered about the butterfly effect of your words, well, you're definitely going to want to stick around for this one.
So is it actually possible for one tiny, microscopic action to completely break a macroscopic system? Just imagine a totally average social media user, maybe someone exactly like you, right? With, say, fewer than 100 followers. They make a single post and it gets absolutely zero engagement. No retweets, no likes, nothing. It's virtually invisible. Now here's the crazy part. Could that isolated action legally be blamed for triggering widespread, catastrophic public chaos? To untangle this incredible paradox, we're going to evaluate this legal argument entirely through the rigorous, impartial lens of statistical physics.
To figure this out, we've got a clear roadmap today. First, we'll outline the causality paradox. Then, we'll break down fluctuations versus phase transitions. Third, we're going to look at the fluctuation-dissipation theorem. Fourth, the physics of the impossible. And finally, we'll deliver the scientific verdict.
All right, let's jump right into part one, the causality paradox.
So we really need to understand how these legal concepts map directly onto physical realities. Because look, if a legal argument claims a direct physical consequence in the real world, it absolutely has to obey the laws that govern that physical world, right? The defense here does something brilliant. They essentially translate the legal actions into the precise language of physics. In a complex network, an everyday social media user is just a particle or an edge node. And the millions of posts flowing every single day, well, that's just thermal background noise, the baseline hum of the system. So a single retweet from our user is just a micro perturbation, a tiny little external push. And that widespread public chaos, that equates to a macroscopic phase transition. The prosecution's argument is basically drawing a direct unbroken line from that tiny micro-perturbation straight up to a massive macro-level phase transition.
Which brings us to part two, fluctuations versus phase transitions.
To really test this out, we need to lock down our terms. First up, what is a fluctuation? Well, it's simply the everyday, unavoidable background noise of a system, which quickly decays without causing any real harm. Honestly, any system made of moving parts, whether we're talking about air molecules bouncing around a room, volatile prices in the stock market, or just opinions flying around on a social network, is never completely still. It jiggles, and that jiggling, that's a fluctuation. Think of it kind of like the constant low-level hum of group chat notifications that you probably ignore every day. It's just background noise. In a normal, healthy system, it gets absorbed instantly. On the flip side, a phase transition is an entirely different beast. We are talking about a massive, systemic structural change. Picture water freezing solid into a block of ice, or a magnet suddenly polarizing, or, in our case, an entire social order collapsing. This isn't just a local jiggle. No way. This requires an immense amount of energy because the whole system is radically reorganizing itself across a massive scale. It's literally a completely different level of physics.
So ask yourself, can a single drop of water create a tidal wave all on its own? The prosecution is trying to equate a totally harmless local fluctuation directly with a catastrophic macro-phase transition. But according to the defense's use of physics, blaming that harmless background noise for a macro-level collapse is a massive category mistake. I mean, a fluctuation is just noise. A phase transition is a structural collapse. Blaming the first for the second, without showing some massive, undeniable chain of events in between, just totally ignores how complex systems actually work in reality.
Let's actually look at the classic sandpile model from the theory of self-organized criticality to see how this plays out. Look at step 1. Grains of sand are just being added to a pile over time. The first, say, 999,000 grains, they do absolutely nothing but build the pile. Then, in step 2, the entire sand pile reaches a highly unstable critical state. It gets incredibly steep. Finally, step 3 happens. One final grain drops, and boom, it triggers a massive avalanche. Now, if you're looking for the true cause of the avalanche, physics tells us it's the accumulated instability of the entire pile back in step 2, not that one final grain in step 3. That final grain, it's just a trigger, nothing more.
And that leads us perfectly into part 3, the fluctuation-dissipation theorem.
Now, this is where it gets really fascinating, because this introduces one of the most profound laws in statistical physics. The fluctuation-dissipation theorem proves that a system's macroscopic response to an external perturbation is entirely determined by its own internal fluctuation spectrum. That sounds complicated, but guys like Albert Einstein and Harry Nyquist formulated this, and it's actually incredibly intuitive. Think of it like this. If you gently tap a solid block of concrete, nothing happens, right? But if you give that exact same gentle tap to a fragile house of cards, the whole thing shatters. The external push, the tap itself, is exactly the same, but how wildly the system reacts, that is entirely determined by how unstable and jittery the system already was on the inside.
So let's apply that exact theorem to our defendant, an edge node with fewer than 100 followers. Their retweet had zero secondary spread, literally zero. In the language of physics, the external perturbation approaches absolute zero. Now, if a near-zero level push supposedly caused massive societal chaos, the fluctuation-dissipation theorem mathematically dictates that the system's internal sensitivity must have already been dangerously, almost infinitely high. The macro-level chaos absolutely wasn't manufactured by the edge node. It was just the inevitable release of the system's massive pre-existing internal tension.
Moving on to Part 4, Physics of the Impossible. You know, sometimes the absolute best way to test a logic chain is just to apply it to different physical environments and see if it actually holds up. And if we apply the prosecution's logic to other fields of physics, we get some absolute absurdities. Just imagine walking into a thermodynamics lab and telling the scientists there that a single air molecule randomly moving around caused the entire room to overheat. Or telling an astrophysicist that a single grain of sand shifted the space-time continuum. Or imagine walking into your local utility company and suggesting that one single electron jittering in a wire somehow crashed the entire national power grid. I mean, you'd be laughed right out of the room. We intuitively know these claims are totally absurd. Blaming a single breath for a specific typhoon completely ignores the massive gap in scale. Sure, a breath pushes air, and yes, a typhoon is made of moving air. But come on, there is a colossal chasm of scale, structure, and required energy between those two things. And the defense rightly points out that the legal system can't just magically leap over that chasm. You simply cannot draw a direct causal line from a microscopic fluctuation to a macroscopic catastrophe without proving an immense, proportionate chain of intermediate steps.
Finally, we arrive at Part 5, the scientific verdict.
When we submit this entire legal narrative to the rigorous scrutiny of complex systems analysis, the conclusion becomes starkly clear. The translated legal documents sum this up beautifully, stating, "A fluctuation is a necessary condition for a phase transition, but it is never the cause." Think back to our models for a second. It might be the final snowflake that starts the avalanche, or that final grain of sand we talked about earlier, but it's the precarious, highly sensitive state of the mountain or the sand pile that is the true structural cause of the collapse. Confusing the trigger with the underlying structural cause is just a severe misreading of how physical reality actually works.
To sum this all up, equating a microscopic action directly with macro-level destruction is a fundamental category mistake. Microperturbations simply cannot directly cause macro chaos. The system literally has to be at a critical state already. A microperturbation just lacks the energy and the reach to force a macro system into chaos all on its own. And honestly, this is where the science and the law are perfectly aligned. Just as physics requires a proportionate transfer of energy to cause a macro event, objective law requires a demonstrable, proportionate chain of causality. You just can't hold the grain of sand legally responsible for the massive structural instability of the mountain. Ignoring that scale creates a huge mistake in both science and law.
Which leaves us with one final profound question to really chew on regarding the balance of evidence, scale, and justice. What actually happens to our legal frameworks when we ignore the hard laws of science? If a legal framework can just casually sidestep the undeniable laws of physical scale and structural causality just to assign blame, well, are we still pursuing objective truth? Or are we just looking for a convenient scapegoat to bear the weight of a system that was already fractured and right on the verge of breaking? That's the ultimate takeaway from this explainer. It's such a fascinating intersection of science and law that really forces us to look much closer at how we define cause and effect in our hyper-connected world. Thanks so much for joining me, and keep questioning the systems around you.